How did the universe form? Did it always exist? Or did it have a starting point? For centuries, scientists believed it to be static and eternal. Even the greatest minds of the time, Newton and Einstein, thought so. But then came Georges Lemaitre, a Belgian priest and physicist. He proposed an idea which was previously unheard of. What if the universe wasn't actually static? What if it had begun from an extremely dense state and has been expanding ever since? This was a radical idea for the time and really difficult for scientists to accept without any proof. But a few years later, Edwin Hubble discovered that distant galaxies were moving away from us. And the farther they were, the faster they were receding. This confirmed that the universe was expanding. Also, much later in 1964, Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation, CMBR for short. It was a faint glow of microwave radiation coming from all directions, often described as an afterglow of the early universe. This further strengthened the belief that the universe is actually expanding. To understand the expansion of the universe better, imagine the surface of the balloon as the universe and the dots as galaxies. When I inflate the balloon, the dots move apart. So it's not the dots that are moving, but rather it's the surface between them that is stretching. That is the same case with the expansion of the universe. Now that we know that the universe is indeed expanding, what happens when we rewind time? Imagine deflating a balloon that you've been inflating for billions of years. As it shrinks, every point on its surface moves closer together. Just like that, space shrinks, galaxies keep getting closer, the universe keeps getting hotter and denser until around 13.8 billion years ago, when our equations suggest that the universe converges to a single point, or singularity, with extreme density and temperature. But what exactly was this singularity? Well, we don't exactly know. General relativity suggests that this point was dimensionless and of infinite density. But these results don't include quantum mechanics. General relativity is very good at describing the universe on a large scale, whereas quantum mechanics excels at explaining the universe at a subatomic level. So until we develop a successful theory of quantum gravity, we cannot say with certainty what happened at the very beginning. When people hear the words Big Bang, they often imagine a huge explosion where matter is thrown everywhere from a single point. But that's not really what happened. The Big Bang wasn't an explosion at all. It was the expansion of space itself. All of space was expanding simultaneously with no central point from which matter exploded outward. Now, although the Big Bang did not make any sound, physicist John Cramer used the CMBR data and converted it into sound frequencies. Now, this is not actual sound, just pressure waves converted into audio frequencies to give us an experience which we can hear. This is what it sounds like. Let's look at the timeline for the Big Bang. First was the Planck epoch stage. This was the earliest stage that we can describe, but our current theories of physics cannot fully explain this era. But it is believed that the four fundamental forces of the current world were all unified into a single force at this point in time. Then was the period of cosmic inflation. This was when the universe expanded exponentially. In the baryogenesis era, matter entered the universe. In the early universe, both matter and antimatter quarks existed, and these kept annihilating each other. But because of reasons unknown, there was just a tiny excess of matter, about one extra matter particle for every billion matter-antimatter pairs. This matter, which survived the baryogenesis era, forms all the objects in our universe today. In the quark epoch, the universe consisted only of quarks, gluons, leptons, and photons in thermal equilibrium, meaning all these elementary particles existed at the same temperature. These elementary particles are what form protons and neutrons, but at this moment, the universe was just too hot for quarks to bind. Protons and neutrons formed in the hadron epoch, when most of the matter-antimatter pairs were annihilated and the universe had cooled enough for quarks to bind. So quarks came together to form protons, and neutrons. In the lepton epoch, there was an abundance of both matter and antimatter leptons in the universe. These included electrons and positrons, and neutrinos and antineutrinos. Around this time, the neutrinos and their antimatter counterparts decoupled, meaning they moved freely in the universe without annihilating each other or interacting frequently with other particles. Whereas electrons and positrons were met with the same fate as the quarks, ending up in a slight excess of matter over antimatter again. The constant annihilation of matter and antimatter released a lot of energy in the form of photons, or light. But these photons were constantly bouncing off of free protons, electrons, and neutrons. This prevented them from moving freely, resulting in the universe being opaque. And by opaque, I don't mean that the universe was dark and empty. No. The universe was glowing intensely, but due to the constant scattering of photons, light wasn't allowed to travel in a straight line. Then came the era of nucleosynthesis. This was when the first nuclei formed, that is, protons and neutrons came together. These included nuclei of hydrogen 1, which are basically just protons, and helium 4. Deuterium helium 3 and lithium 7 nuclei were also formed in very small amounts. In the recombination era, it was cold enough for electrons to bind with the nuclei created in the nucleosynthesis era. This resulted in the formation of neutral atoms like hydrogen, helium, lithium, and deuterium. And now, since the electrons and nuclei have combined and have settled into more stable states, the photons aren't constantly bouncing off of something. This allowed them to move freely, making the universe transparent. This photon decoupling released radiation in the form of the cosmic microwave background radiation, which can be seen even today. Then, in the Dark Ages, the universe was filled with neutral hydrogen and helium. Everything was completely dark because no stars had formed yet. But as a first step towards star formation, molecules started forming. Now, the gas present at the time was not spread evenly. Small clumps of gas had formed due to gravity. These clumps eventually became stars. And as more stars kept forming, again due to gravity, galaxies began to form. Once these stars and galaxies formed, they released a lot of UV radiation, which resulted in the neutral hydrogen ionizing. This was the epoch of reionization. Because if you remember, hydrogen was ionized earlier until it gained electrons and became neutral. Now, though we said that the universe became transparent in the recombination era, there still were neutral gases spread throughout the universe. Now, because of reionization, radiation was allowed to travel farther distances, similar to how it is today. After reionization, more stars and galaxies formed, with peak star formation around 3 to 4 billion years after the Big Bang. As more and more stars and galaxies kept forming, a cosmic structure began to form with galaxy clusters and superclusters. Today, the structure has fully developed and the universe is still expanding rapidly, and in fact, expansion is accelerating. So, what existed before the Big Bang? Well, we have no idea, but since the Big Bang is essentially the beginning of space and time itself, it can be considered a reasonable starting point. Many theories exist, like the Big Bounce, for example, but it is a very large topic with a lot of details, so it's a matter for another video.